ocean is the lifeblood of our planet. It supports rich marine ecosystems, generates most of the oxygen we breathe, and affects the globe's weather with its currents. It may also hold the key for one of the most productive crops of the future. Recent studies have discovered a strain of microalgae with fascinating qualities that we can take advantage of. Researchers have found that this species of microalgae can be manipulated to generate large amounts of lipids, also known as fats or oils, in a short period of time. The algae is starved for a number of days and then fed acetate, a simple carbon-based solution, which they then use to generate fat.
Chlamydomonas and algae, sort of the microalgae, are a really good potential source for lipids for a few different reasons, but one is their photosynthetic efficiency is much higher than most plants, and so they have the ability to bring in lots of carbon to make oils.
There are many common everyday uses for these lipids generated by the microalgae. For example, they can be used in the production of cosmetics, industrial lubricants, biofuels, and nutritional supplements.
So these lipids can be used for lubricants, for all types of machinery. The more fancy the machinery, the more fancy the lubricants usually need to be, and so different types of lubricants, cosmetics. I'm sure you've seen lots of products that tout how they are made from plants and all natural extracts.
Currently, the biggest hurdle to mass produce these lipids is the cost, as it is expensive to feed large amounts of acetate to the algae. Ideally, the algae would produce lipids phototropically, which means using the sun and the carbon in the atmosphere as an energy source.
Why can't we just feed them acetate and have them produce lots of lipids? And that just goes to, it's just again a cost thing, so you'd have to pay for carbon in the form of acetate and feed them carbon. So the ideal situation would be to make it so they're growing phototrophically. So they're bringing in carbon dioxide from the atmosphere and they're using that to produce oils, and that would make it carbon neutral in the sense that you're bringing carbon back from the atmosphere and then burning it and putting it back in, but it would be a carbon neutral cycle.
Researchers have yet to understand how these mechanisms work, but there is promise that as we understand more about them, we will be able to increase lipid yields in a cost-effective manner.
The exact mechanisms of how are still a little bit fuzzy. Actually getting the oils out of the microalgae is one of the big bottlenecks. The other one is the yield side of it.
This research seems to be promising for the future. There are still some pieces of the puzzle to be put together, but it is a good place to work from.